Hello friends, welcome to SSP Math. Now we are taking some problems on singular point using Frobenius method. So problem is solve using series solution 3x into d2y by dx square plus 2dy by dx plus y equal to 0. So if we compare this differential equation with p0 of x into d2y by dx square plus p1 of x into dy by dx plus p2 of x into y is equal to 0, then we have to check first ordinary point or singular point. So here p0 of x is equal to 3x and therefore p0 of 0 is equal to 0. So p0 of 0 equal to 0 and therefore x equal to 0 is not ordinary point. So x is equal to 0 is not ordinary point, then that point x equal to 0 is singular point here. And if x is equal to 0 is singular point, then we have to check this point is regular singular point or irregular singular point. So how we check? We have to check here two conditions for that. First one is limit x tends to 0 x into p1 of x upon p0 of x. If this limit is finite, limit x tends to 0 x into p1 of x. What is the value of p1 of x? P1 of x is 2 upon p0 of x is 3x. So this x's get cancelled, limit is 2 by 3 and this is finite. So this is the first condition. And second condition is we have to check again limit x tends to 0 x square into p2 of x upon p0 of x. If this limit is finite again, then we can say that that point is a regular singular point. So limit x tends to 0 x square, p2 of x is here 1 upon p0 of x is 3x. So 1x get cancelled. If you put x equal to 0, limit is 0 and this is also finite. Therefore we get both limit finite and x equal to 0 is singular point. So we can say that therefore x equal to 0 is regular singular point, regular singular point of equation 1. Equation 1 means that is given differential equation. So if x equal to 0 is a regular singular point, then we have to take y is equal to summation of k varies from 0 to infinity ak into x raised to m plus k is the solution of given linear differential equation. But in that differential equation here y dy by dx a d2y by dx square. So if you take y equal to this, then from y or to write dy by dx. What is dy by dx here? Summation of k varies from 0 to infinity ak, derivative of x raised to m plus k is m plus k into x raised to m plus k minus 1. And again if you take a double derivative of this, that is d2y by dx square is equal to summation of k varies from 0 to infinity ak m plus k, derivative of x raised to m plus k minus 1 is m plus k minus 1 into x to the power m plus k minus 1, that is k minus 2. Okay, now we have to put all these three values in given differential equation. Therefore given differential equation becomes 3x into d2y by dx square. So d2y by dx square is summation of k varies from 0 to infinity ak into m plus k minus 1 x to the power m plus k minus 2. So this is 3x into d2y by dx square plus 2 into dy by dx. So dy by dx is summation of k varies from 0 to infinity ak into m plus k x to the power m plus k minus 1 and plus y is summation of k varies from 0 to infinity ak into x raised to m plus k is equal to 0. This is the power series expansion of given differential equation. Now after simplification we can write here one more step. Summation of k varies from 0 to infinity means multiply this 3x. So this 3 write as it is, and if you multiply x inside, then we will get ak into m plus k minus 1 into x to the power m plus k minus 2 into x. So if we take addition of power, that is m plus k minus 2 plus 1, that is minus 1, plus remaining terms as it is, only change is multiply x to this and denote this equation by 2, say. Okay, now we have to find indicial equation. So how we find indicial equation? For that we have to equate the coefficient of lowest degree term. Now observe this carefully. Here k starts from 0. So what is the lowest degree term of x? In this equation if we put k equal to 0, k equal to 0 के लिए जो भी वैल्यू होगी वो सबसे लोवेस्ट पावर होगी x की. करेक्ट. देखो यहाँ पर मैंने यदि k इक्वल टू 0 पुट किया तो कि x की पावर क्या मिलेगी? m minus 1. If we put here k equal to 0, then we get power of x is m minus 1. But here if we put k equal to 0, power of x is m. So m is greater than m minus 1. So for indicial equation we have to equate the coefficient of lowest degree term. Coefficient of lowest degree term, that coefficient is x to the power m minus 1 to 0. So the coefficient of lowest degree term is x, lowest degree term is here x raised to m minus 1, so to equate that 0. So first one is here 3. For k equal to 0 we will get here x raised to m minus 1, so we have to put k equal to 0. So 3 into a0. देखो यहाँ पर हमें k की वैल्यू 0 पुट करनी, तभी मिलेगा x raised to m minus 1. k equal to 0 यदि पुट किया तो a0 m into m minus 1. This is the coefficient of x raised to m minus 1 from first series, plus 2 into, here also we have to put k equal to 0, a0 m, and here x to the power m. So coefficient of x raised to m minus 1 is from only first two series. Equate this with 0. Now if we take a0 common here, then we will get 3m into m minus 1 plus 2m equal to 0. Since a0 is not equal to 0, and therefore this 3m into m minus 1 multiply 3m inside, that is 3m square minus 3m plus 2m equal to 0. If we simplify this, then this becomes 3m square minus m equal to 0. So this is the indicial equation of given linear differential equation, and this is quadratic equations. We have to find roots of this. That roots are, if we take m common here, then we will get 3m minus 1 equal to 0, means either m equal to 0 or 3m minus 1 equal to 0. Using this we can write m equal to 0 or m equal to 1 by 3. So these are the two roots of indicial equation 3m minus m equal to 0. Now we have to find the nature of solution. So which case is applicable here? First root is say m1 equal to 0, and second root say m2 is equal to 1 by 3. So m1 equal to 0, m2 equal to 1 by 3 means roots are distinct and not differing by an integer. If you take m1 minus m2, we get 0 minus 1 by 3, that is minus 1 by 3, and minus 1 by 3 is fraction, that is not integer. So we have to apply here case number 1, and by using case number 1, solution is y is equal to c1 into y at m1 plus c2 into the value of y at m2. So we have to find now y. Now what is y? Y हमने assume किया था summation of akx to the power m plus k. Okay, so for y what we want the value of ak, means a0, a1, a2, a3 and so on. Okay, Now using equation 2, we have to equate again lowest degree term of x, means power of lowest degree term of x to the 0, coefficient of lowest degree term of x to the 0. Here k इक्वल टू 0 के लिए हमें मिला x टू द पावर m माइनस 1. अब देखो k इक्वल टू 1 के लिए लोवेस्ट डिग्री क्या होगी, 0 के लिए तो ऑलरेडी यूज किया है. अब फॉर k इक्वल टू 1 यहाँ पर आएगा 1 गेट कैंसल, मीन्स x रेज टू m मिलेगा. Here also 1 get cancel, x raised to m means next one we have to equating the coefficient of x raised to m to 0. Okay, now equating the coefficient of x raised to m to 0 from equation 2. अब x raised to m का coefficient यहाँ पर कब मिलेगा हमें, if we put k equal to 1, so 3a1 m plus 1 into m ऐसा मिलेगा, 3a1 into m plus 1 into m. This is the coefficient of x raised to m from first series, plus 2 times from this series, if you put k equal to 1 here, a1 m plus 1, 2a1 m plus 1, and from last series here, when we get x raised to m term, if we put k equal to 0, so k equal to 0 put किया तो यहाँ पर coefficient of x raised to m मिलेगा हमें a0, so plus a0 equal to 0. Okay, now from first two terms we can take a1 common, and this 3m into m plus 1 plus 2 into m plus 1 is equal to minus a0. Okay, so from this if we take m plus 1 common here, a1 into m plus 1 if we take common, यहाँ पर क्या रहेगा ब्रैकेट में 3m plus 2 is equal to minus a0, and therefore a1 मिला हमें minus 1 upon m plus 1 into 3m plus 2 into a0. So this is the value of a1. Same we have to find a2 now. अब देखो a1 के लिए हमने क्या किया, कोएफिशिएंट ऑफ x टू द पावर m इक्वेट किया, फॉर k इक्वल टू 1 के लिए मिला. अभी लोवेस्ट पावर ऑफ x कौन सी होगी, x रेज टू m माइनस 1 हो गई, x रेज टू m हो गई, उसके बाद आएगी x रेज टू m प्लस 1. सो व्हेन वी गेट दैट फॉर k इक्वल टू 2 के लिए, k इक्वल टू 2 के लिए हमें क्या मिलेगा, x टू द पावर m प्लस 1. नाउ वी हैव टू equating the coefficient of x to the power m plus 1 to 0. Okay, now when we get here x to the power m plus 1, if we put k equal to 2, देखो 2 minus 1 लिया तो यहाँ पर 1 मिलेगा, मतलब x raised to m plus 1 मिलेगा. मीन्स फॉर k equal to 2 के लिए इसका एक्सपेंशन क्या आएगा, 3 into a2 m plus 2 m plus 2 minus 1, means that is 3a2 m plus 2 m plus 2 minus 1 is m plus 1. Same in second series, plus 2 times, you have to expand this again for k equal to 2, so 2a2 m plus 2, 2a2 m plus 2, and in third series we want coefficient of x raised to m plus 1, so we have to put here k equal to 1. यहाँ पर क्या करना पड़ेगा, k equal to 1 पुट किया तो x to the power m plus 1 मिलेगा. so यहाँ पर मिलेगा हमें plus a1. a1 is the coefficient of x raised to m plus 1, so plus a1 equal to 0. Okay, now from these two terms we can take a2 common. So if we take a2 common, then remaining terms 3 into m plus 2 m plus 1 plus 2 into m plus 2 is equal to minus a1 मिला. so a2 into, देखो यहाँ से हम m plus 2 कॉमन ले सकते हैं. so if we take m plus 2 कॉमन, ब्रैकेट में क्या रहेगा, 3 into m plus 1, that is 3m plus 3 and plus this 2 is equal to minus a1. Okay, and therefore a2 is equal to minus 1 upon m plus 2 into what is this 3m plus 5. 3m plus 5 into a1. And what is the value of a1? a1 already find kiya hai, minus 1 upon m plus 1 into 3m plus 2 a0. So this minus and this minus is plus, means put the value of a1 here, then minus minus plus 1 upon a1 में m plus 1 3m plus 2, this is a1, okay, into this m plus 2 3m plus 5 into a0. So this is the value of a2. Now we will get here a1 in terms of a0, this a1 in terms of a0, a2 in terms of a0. Similarly we can find also a3 in terms of a0. No need to find a3. Now what is the solution of given differential equation? That is, solution क्या assume किया था हमने, y is equal to summation of k varies from 0 to infinity ak into x raised to m plus k. Okay, now this is equal to a0 in for k equal to 0 expand किया तो a0 x raised to m plus a1 x raised to m plus 1 plus a2 x raised to m plus 2 plus so on. Okay, now for m equal to 0, m की हमें दो वैल्यूज मिली थी, m equal to 0 and m equal to 1 by 3. So first we will find solution for m equal to 0, means y, this is m1 say y at m1 is equal to 0 is equal to क्या आएगा a0 plus a1x plus a2x square plus so on. Now keep a0 as it is. Now what is the value of a1? a1 is minus 1 upon a1 क्या है minus 1 upon m plus 1 into 3m plus 2, बट इसमें m की वैल्यू यदि 0 पुट की तो वो मिलेगा 1 into 2 a0x plus a2. What is a2? a2 is this, so a2 is plus 1 upon, here m equal to 0, 1 2 2 5 into a0x square plus so on. So after simplification, if we take a0 common here, then we will get 1 minus x by 2, and what is this, 5 into 2 10, 10 into 2 20 plus x square by 20 plus so on. So this is the value of y at x equal to y at m1 equal to 0. Now we have to take second root, that is m2 equal to 1 by 3. So if we take m2 equal to 1 by 3, then y at m2 can be written as, here if we take m equal to 1 by 3, okay, so a0 x to the power 1 by 3 plus a1 x to the power 1 by 3 plus 1, 1 by 3 plus 1 is 1 by 3 plus 1 is 1 by 3 plus 1, we will write one more step here, and plus a2 into x to the power 1 by 3 plus 2, okay, plus so on. So after simplification, what is this? This is a0 x raised to 1 by 3 plus, if you take x raised to 1 by 3 common from this, x raised to 1 by 3 if you take common, then a0 प्लस देखो x रेज टू 1 by 3 प्लस 1 को हम लिख सकते हैं x रेज टू 1 by 3 into x a1x. Same here, if you take x raised to 1 by 3 plus 2, we can write x raised to 1 by 3 into x square, and if you take x raised to 1 by 3 common, a2 into x square plus so on. So put the value of a0, a1, a2 here is equal to x to the power 1 by 3 into bracket a0, keep as it is. Now what is a1? a1 is this, minus 1 upon m plus 1, so minus 1 upon 1 by 3 plus 1, 1 by 3 plus 1 is 3 by 1 by 3 plus 1 into m equal to 1 by 3 put किया तो 3 get cancel, 1 plus 2 is 3 into a0 of x. plus a2. What is the value of a2? a2 is this plus 1 upon 1 by 3 plus 1 into m equal to 1 by 3 पुट किया यहाँ पर देखो तो 1 by 3 1 3 get cancel, so 1 plus 2 is 3, then m plus 2 that is 1 by 3 plus 2 and 3m plus 5 again 3 get cancel, 1 plus 5 into a0 x square plus so on. Okay, so after simplification what is this? This is equal to x to the power 1 by 3 into a0 take common, so here 1 minus 1 by 3 plus 1, that is 3 plus 1 is 4 by 3, 4 by 3 into this 3 get cancel, that is x by 4. Okay, plus same here 4 by 3 and these 3 get cancel, 4 by 3 that is 3 get cancel, 4, 1 by 3 plus 2, 1 by 3 plus 2 is 3 into 2 6, 6 plus 1 is 7 by 3 into 6 into x square plus so on. So after simplification this is a0 into x to the power 1 by 3, 1 minus x by 4, 3 1s are 3, 3 2s are 6, so 7 2s are 14, 14 multiply by 4, that is I think 56 plus 1 by 56 into x square plus so on. So this is the value of y at m2. Now we have to write final solution here. So final solution is y is equal to c1y at m1 plus c2y at m2. So you put the values of c1y at m1 and y at m2 here, that is the final solution. c1y at m1 means this value and y at m2 this value, put in final answer, that is the required solution of given linear differential equation with variable coefficient. Now you try this problem at your level. Problem is solve 9x into 1 minus x y double dash minus 12y dash plus 4y equal to 0. So we can solve this problem using case number 1 also. देखो स्टूडेंट, ये प्रॉब्लम के लिए हमें 20 मिनट्स लगे. इफ यू प्रैक्टिस दिस देन यू कैन सॉल्व दिस प्रॉब्लम इन 10 minutes. So do practice. If you have any doubt then comment on comment section or contact me personally on my WhatsApp number. Thank you so much.